You're welcome once again. Today we are looking at a topic that's very important. You know, this matrices and linear transformation. It was formerly in elective maths, but you know, as of now, WAEC has added it to the core maths syllabus. So it means that this topic is important for those who are studying core maths, that's general mathematics, and further mathematics, which we normally term elective maths as well. Right? Now, a matrix is a rectangular array of numbers, okay? Rectangular or a square array of numbers. Normally, it is enclosed in parentheses, right? Or a bigger bracket, as you can say. So, a typical example of a matrix, we can have something like this: A, B, C, and D. This is a matrix. Let's say M is equal to A, B, C, and D, right? Now, the matrix is always represented with a capital letter, and then the element inside the matrix itself, the element, all these ones are called the elements. They are represented by what? Small letters. Are you okay? And one thing I want you to also notice that matrix is always represented in this form. It's written as this. It goes here 1, 2, 3, 4, right? So if I tell you to read this particular matrix, it's A, B, C, D. So if I give you something like V equals X, Y, W, V, so this is how it's going to be X, Y, W, V. You don't read it X, W, Y. No, that's how we read it. It goes this way, it comes this way, and then it goes that way. Are you okay? That is how we read a matrix. Now, matrix is important for normally those who sell different commodities of different brands, right? So, for instance, if somebody, a car dealer is selling, let's say, Toyota, Hyundai, which brand again? Benz and all those stuff. And you see, Benz also have different models, right? Toyota has different models. We have the Toyota Vit, we have the Corolla, we have the Camry, all those stuffs, right? Those are the people who need matrices a lot, right? They need matrices a lot to compute whatever information they need to compute, right? So without much ado, let's look at types of matrix, right? We are looking at types of matrix. Now, the first type of matrices we are going to look, type of matrix. The first one is called a column matrix. Let's start with a column matrix. So a column matrix is a matrix that is made up of only one column. Example, I have 2, 4. Are you getting that? This is a column matrix. And then since we have a column matrix, you will expect that we will have what we call a row matrix, right? And then a row matrix is a matrix that is written in a row from, like, I have 2 and then 4. This is what? A row matrix. Are you okay? And then another matrix we have what we call 2 by 2 matrix. Now, 2 by 2 matrix is a matrix which has 2 columns and then 2 rows. A typical example, I have A, B, C, and D. This is a 2 by 2 matrix. You realize it has 2 columns and then, 2 rows and then 2 columns, right? Now, we also have 3 by 3 matrix, okay? Now, a 3 by 3 matrix is the type of matrix or the kind of matrix that has 3 columns, A, B, C, D, E, F, J, W, V. You realize that it has 3 columns and then what? 3 rows. It has 3 rows and then 3 columns, okay? We can also have what we call a rectangular matrix. Now, all these ones is a square matrix. 2 by 2 matrix is also known as a square matrix, okay? Now, it is called a square matrix because, of course, you see the number of elements in a column is equal to the number of elements in a row. And we all know that for square, both the length and the width are what? Equal, right? So, 3 by 3 matrix can also be said to be what? A square matrix, because the number of rows is equal to the number of columns. You see that? Now, let's go to rectangular matrix. Now, a typical example of rectangular matrix is 3 by 2 matrix, right? Now, so 3 by 2 matrix actually means you have 3 rows, A, B, C, then E, F, G. You realize that I have 3 rows and I have what? 2 columns. So this is a typical example of what? A rectangular matrix, okay? Now, we also have another kind of matrix which we call a zero matrix. Now, a zero matrix, of course, as the name suggests, a zero matrix is a matrix which has all the elements to be zero. Now, a typical example of a zero matrix is when I have m equals 0, 0, 0, 0. This is what? A zero matrix. Another example is when I have all the elements are 0. So if I have 3 by 3 matrix and all of them are 0, this is also what? A zero matrix, right? And then let's look at the last type, which we call a unit matrix. A unit matrix is the same as the identity matrix. So identity matrix is given by 1, 0, 0, 1. So an identity matrix is a matrix which has the whole row, one diagonal being what? 1. Another example for 3 by 3, we can have something like 0, we can have something like 1, 0, 0, 0, 1, 0, 0, 0, 1. You realize that the diagonal, the whole diagonal is what? 1. Are you getting that? So when you have this, it's also called an identity or what? A unit matrix, okay? All right. So now let's look at how we add 2 or more matrices, right? When we have 2 or more matrices, how we add them. So let's now look at addition and subtraction of matrix. So let me clean this side of the board. So now let's look at addition and subtraction. Addition and subtraction of matrix. So if I have a matrix M equals A, B, C, D, and I have a matrix N equals X, Y, W, Z, right? Then, if I tell you to find M plus N, this one, M plus N, means you are adding the element of M to the element of what? N. And in matrix, when you have 2 elements and you are adding them, this is what happens. The first one is added to the first one, second is added to the second, this is added to this, and that is added to that, okay? So the final answer for this one is going to be A plus X, because we add the first one plus the first one, second plus second, so B plus Y. Now third plus third, so I'm going to get C plus W, and then fourth plus fourth, I'm going to get D plus what? Z. That's all. I'm done. Now when you are subtracting 2, you follow the same precedent, nothing changes. So if I want you to find N minus M, it means the coordinate of N, remember N first, so X, Y, W, Z minus the coordinate of M, A, B, C, and D. You realize that this one becomes X minus A, right? Since these are variables, this is how I'll get it. Y minus B, so this one becomes Y minus B. Now the fourth minus the fourth, that's what? W minus C. And then this minus this, that was what? Z minus what? D. That is all. That is how we add or subtract a matrix. Okay. So let's have an example of this nature. Then we will look at. Let me write a question here. So for instance, an example. If I have A equals 2, 4, 5, 3, and I have B equals 3, 4, 7, 8. Now evaluate, so I'm using this as an example, evaluate I, A plus B, and then I, B plus, let me say B minus A, right? So let's solve these two, then we'll draw the curtain on this particular episode. Then the next episode we'll look at how to multiply matrix and how to no. Alright, so let's solve these two questions. So the first one says I should evaluate A plus B. So A plus B means the coordinate of A, which is 2, 4, 5, 3, plus the coordinate of B, that is 3, 4, 7, 8. Right? So you realize that if I'm adding first plus first, right? So 2 plus 3 is going to give me 5. Now 4 plus 4 is going to give me 8. Now 5 plus 7 is going to give me 12. And then 3 plus 8 is going to give me 11. So that's all. It means my A plus B is going to give me this, right? Now let's look at the next one. The next one, we are supposed to find B minus A. Now B minus A means the coordinate of B, which is 3, 4, 7, 8, minus the coordinate of A, that is 2, 4, 5, 3, right? So at the end, I'm going to get now 3 minus 2 is going to give me minus 1. 4 minus 4 is going to give me 0. Now 7 minus 5 is going to give me 2. And then 8 minus 3 is going to give me 5. Therefore, my B minus A is going to give me negative 1, 0, 2, 5. So this is where we draw the curtain on this episode. Now on the next episode, we are going to look at multiplication of a vector by a scalar. And then we are going to look at multiplication of 2 by 2 vectors itself. So until we meet next time, I'll say goodbye for now.